Hello, welcome to our EAS 574 final project. Our project will be conducting a popularity prediction analysis on a Spotify dataset. So to introduce ourselves, my name is Brett Chow. I'm joined alongside Jishnu Chatterjee and George Wang. So our main objective for this project is to formulate customer-oriented strategies for both Spotify, the platform, and its partner artists and production companies. So to answer that objective, we are going to answer a very important business question, which is we chose track two, which is the popularity prediction, and we're going to answer these three questions. So, given a song's features, can we estimate its popularity score? What are the key features that influence a song's popularity on the platform, and how can artists and producers use these insights to shape their musical decisions and increased likelihood of success? So we'll be answering all these questions throughout the presentation. So we have collected our data from a Spotify Tracks dataset from Kaggle, and you can see these are some of the features here. But most importantly, we're going to focus on the popularity feature. That'll be our target variable for this project. And if you flip through the next two slides, you're going to see all the other features that we're going to use to try to estimate popularity score and what increases popularity.
Hey, thanks a lot, Brad, for the warm introduction. My name is Jish. I'll be quickly going over some of the data transformations and the modules we utilized in order to accomplish our predictive modeling tasks. Looking into specifically the raw data set that was given to us, we have done sets of transformation inclusive of dropping certain unquantifiable features in order to plug into the model, and some of the features that we were able to drop are sort of indicated over the slide here, such as song ID, artist, album name, song name. We did see different sets of data types, which we wanted to either drop or convert. We also did go ahead and rename a few columns in order to perform one-hot encoding, as well as um, get rid of many null values within the dataset. So this is a sort of model that we were able to produce after different sets of transformation. Obviously, the ones we did go over are one set over many transformations that we were able to perform. But we also went ahead and did a few pre-analysis and presets of illustration. As you can see over here, we do have a visualization of popularity scores against all 15 features that we were able to primarily select. And just looking at the data set itself, we see a wide range of data, which makes it a better visualization and a good indicator in order to plug in different sets of predictive modeling frameworks to accomplish our modeling task. And similarly, looking at the popularity distribution itself, as well as the correlation heat map, we can see that a total count of different sets of features do showcase a unbalanced data set, especially looking at the popularity distribution. We do see everything under the 80th percentile. And going over to the right hand side with the correlation heat map, we do see a wide range of data from +1 all the way to -1. Hence the reason why we did use and leverage some of our predictive modeling frameworks in order to accomplish our task, which will be taken over by George.
Hey, so I will go through the model training part and the function part of the code. So the first thing is that we do a separate of the dataset into training and testing dataset, and then we feed the linear and lossy models for for the project. The linear regression we use as a baseline here, and then also add like more regulations to remove any important features. And then we develop a hyperparameter tuning random forest. So this will help us to handle any non-linear data, and this also have to provide like feature importance metrics, which can be found in the next slide. So in the next slide, we evaluate the performance of the three models. So meaning you see R-square score and the MSE. So the random forest best fits the project as it has a higher R-square. So this help to give more word runs, and it also has a lower MSE score. So this means it can provide better predictions. So we also get a visualization of the RF performance. So you can have a directly view of the predicted and versus the actual popularity by the random forest. So in the next slide, we get a list of the top 10 feature important from the random forest in a descending order. And we also generate a table for that. So you also have a better illustration based on the test result. So the next part of the code is that so the next slide of the code is that we get a blueprint creation. So is that we use the top 10 features from the previous random forest, and then we use that features to retrain the lasso based on that. So if the lasso coefficient is larger or equal than 0, we can target the 75 percentile. So if it's less than 0, we only target the 25 percentile. And then we define a health function so to predict the popularity. So we accept the song's features, and then it will return the predicted popularity score. And we also define a function to suggest for the improvement. So it will compare song's features to the blueprint we created as a baseline, and it will provide actionable suggestions to increase or decrease any specific attributes. So the last part of the case here is that we use a case example to illustrate the results. So we predict the popularity of a test song we get from the dataset, and we also provide suggestions based on the test song to bring the song in the high performance range. So I will bring back to Brad for the result and conclusion.
Yeah. So we have our all of our top features by model. So we're gonna definitely focus on random forest regressor, as George pointed out. That was the one that performed the best. So acousticness, danceability, duration, valence, tempo, speechiness. But I also want to point out the common top features between all three models, which is danceability, speechiness, and valence. And this should give us a good idea on how to improve popularity score for artists. So to summarize, based off of our regression models, we want to focus on those random forest model features, specifically danceability, speechiness, valence. So based off of our improvement suggestion analysis, we want to increase danceability, speechiness, and valence to increase popularity score. So our strategy for underrated artists is that they should make more songs that make people happy, make people want to dance, make people feel more lively. And this could include putting more upbeat audio or singing something more positive through vocals. And I think underrated artists should get into genres such as pop, hip hop, or EDM in order to capture the type of music that will increase popularity. Thank you for listening to our presentation. We hope you guys learned something from this.